Okay, is everybody back?
Yes, sir.
Okay.
Yes, sir.
So imagine that you want to measure a phenomena like income. So एक तरीका तो ये है ना कि you directly ask a question, what is your monthly income? If you are confident that people would provide their true income up to a greater extent, तो फिर तो कोई issue नहीं है. You can just record the numbers. But if you think that maybe the income would be underreported and it would not be truly reported, so what the researchers usually do, they ask a series of questions like X1 representing one question, X2 representing another question, and XP representing another question. Like, for example, in your questionnaire, you could have asked 20 different questions, and all of those questions are actually asking about the possession of certain household asset. As I said, it can be as simple as, for example, do you have a TV in your house? Do you have electricity? Do you have this thing or do you have that thing, like the household utilities? But it can also be asking something about the structure of the house in which the person is living. Are you living in Paka house or Kacha house, or what is the nature of the toilet? Is it a standard toilet or is it just there or not, right? And the purpose of all these 20, 25 questions would be to get some idea about the economic conditions of the person who is living in that household, okay? Mostly the answer would be in the form of yes or no. So mostly if you are asking question about the household asset, in majority cases, the person would not have any hesitation to give you that answer. So the technique of factor analysis and the principal component analysis is then used to come up with an idea.
Sir, ये screen share कर दे kindly, please.
Okay, again, I just forgot. Sorry. So if you have asked a series of questions, like for example, this P can be, let's say, 20 different questions. So if you have asked different questions on the possession of sorry. Okay. If you have asked questions on different possession of different assets, so the technique of factor analysis of principal component analysis can be used to come up with something that we call asset index. Okay. How this asset index is actually obtained, ये तो मैं आपको बाद में बताऊंगा ना, but it can be something like combining the information by something like this. A1x1 plus A2x2 plus and so on, plus AP XP. Okay, something like this, where these A1, A2, AP, they are the weights to be determined. But the basic purpose is that by asking individual questions, you are applying a technique like factor analysis or PCA. The rest is how you actually apply it, but just take it for granted for the time being. And you come up with an idea of combining the information on all these 20 different variables in the form of one single new variable that you can call asset index. So asset index would then be a single variable which would be obtained by combining information on, for example, these 20 different variables. And this asset index would then be used as a proxy for income. So if you think that income cannot be properly measured or maybe underreported, So one of the tricks that researchers do, they come up with what they call asset index, right? And asset index is actually obtained by using the technique of factor analysis or principal component analysis. So this is one practical application that researchers do in real life, okay? Even if you have heard something about the corruption perception index, आपने सुना है ना ये ट्रांसपेरेंसी इंटरनेशनल जब रैंकिंग करती है ना कंट्रीज की on the basis of corruption perception, and when they say, for example, which country is the most corrupt and which one is the least corrupt, they use similar ideas. They ask a series of questions. Yeah.
सर ये तो हम सिर्फ फिर प्राइमरी डेटा के लिए यूज करेंगे ना?
No, you can use it on secondary data, right? Keep in mind that the techniques that we are going to use in this course, mostly they do not make any distinction between primary data and secondary data, right? Your purpose was basically decide which technique is more appropriate. So therefore, there is no restriction whether you should collect primary data or whether you should collect secondary data, okay? Like for example, when you are coming up with the idea of asset index in the style that I have just shown, you may be collecting your own data like fresh data for your research, or maybe you have access to a secondary data, but when you look at the secondary data, you come up with the idea that I can combine information on some of the variables in the form of some new variable. And you say, why not apply the technique of PCA or factor analysis to combine information on some of the variables over there, right? And get a new variable. So there is no restriction of primary or secondary variable, okay? Some more examples would actually come into discussion as we actually apply these techniques. Is it okay for the time being?
Thank you so much, sir.
Okay. So this discussion would actually give you an initial idea of using the technique, okay? The next thing is, okay, one other thing that we would also be, in a sense, learning in our discussion, that when it comes to factor analysis, we can divide factor analysis into two broader categories, as you can see right here on the screen. One would be called EFA, and the other one would be called CFA, exploratory factor analysis versus conformatory factor analysis. Exploratory factor analysis, or its other version that we will call PCA, okay? Here, you do, you will carry out EFA or PCA on a data when the researcher is uncertain about how many factors may exist among a set of variables, right? In the context of factor analysis, the new variables that you get from the actual variables is given the name factor. So if you don't have any idea in advance, like for example, how many new variables that I call factors can represent the large number of original variables, okay? Should I summarize the information on all the variables in the form of just one new variable or one factor? Or should I use more than one factor to summarize information on all the variables in my data set, right? If that is the issue, then you will go for exploratory factor analysis. You are just exploring the data and coming up with a possible answer for the number of factors, the number of new variables which can represent the actual variable. But in confirmatory factor analysis, what you do it when the researcher has strong theoretical expectations about the factor structure before performing the analysis. If you have some information in advance about the possible factors that you can use for your analysis, okay? If, for example, you are already sure, either on the basis of your own knowledge either on the basis of an EFA that you have run before, or on the basis of some theory from your field, which tell you that the information available in these variables can be summarized in the form of these factors, and those factors also have got some names, right? Then, for example, you would say that I should actually confirm, in a sense, test certain hypotheses of the relationship which exist among the actual variables and the new variables that I call factors. So if your purpose is to start with something already known to you and you want to, in a sense, confirm it using hypothesis testing and further modeling, right? Then that area of factor analysis would then be called confirmatory factor analysis, okay? When we will be actually using these techniques, I will come up with specific examples. Like, for example, the example that I have just given, getting, in a sense, the asset index from the data on household assets. This is a type of exploratory factor analysis, okay? But in confirmatory factor analysis, some information on the possible factors would be already known or provided or given by the theory. And your purpose would be just to start from that point onward and study different relationships, confirm different relationships, confirm or verify certain hypotheses which describe relationships among those things, okay? So that would be actually the job of confirmatory factor analysis. So EFA is the initial phase of factor analysis, and CFA is the ending phase of factor analysis. And confirmatory factor analysis will be a very much important part of SEM, structure equation modeling, that we will be considering in our discussion. Okay, so I will just skip these details for the time being. Another technique by the name of cluster analysis is also a very useful technique, particularly those who are interested in the field of marketing, although it's not just for marketing research, but because I'll be taking specific examples from over there. So this is one of the very useful technique that you can use over there. Broadly speaking, cluster analysis is a multivariate approach for grouping observations based on similarity among measured variables, okay? In contrast to the dependence methods, cluster analysis is basically also an interdependence technique. Why it is an interdependence technique? Because when you will be doing this technique, you don't need any information on which variable is dependent and which variable is independent. You just take all of them together. And the purpose is to take information on these variables and try to determine whether you can divide all the objects in your analysis into a number of groups or not. So cluster analysis is basically something like group formation, dividing all the objects into a number of groups. Each group is then given the name of a cluster, and such that the units within this group are as similar as possible. How we decide similarity or dissimilarity, this would be clarified when we actually run this procedure of cluster analysis. But the basic purpose of cluster analysis is group formation, dividing the number of units, the objects, into a number of groups, a number of clusters. This is a very important tool for identifying market segments. I hope you have heard something about market segmentation, dividing the markets on the basis of characteristics provided by the customers, okay? So market segmentation is a very useful procedure. We would have some more discussion on this idea when we actually study the application of cluster analysis, okay? So cluster analysis can help you in market segmentation, right? So using the information provided by the customers in the form of different variables in your data set, cluster analysis can help you to divide the customers into a number of groups such that the customers within the same group would possess as similar characteristics as possible, okay? And the customers in one group would be different from the customers in another group. And in a sense, this can help you coming up with better marketing strategies. So therefore, one of the purpose of cluster analysis would be to divide the objects into a number of meaningful groups and then use this information on subgrouping for further analysis. Okay. Multidimensional scaling is also an interdependence technique, because again, you don't need to mention dependence or independence, but somehow this is closer to the idea of cluster analysis. Cluster analysis, in a sense, tries to identify which units are actually similar to each other and which units are dissimilar, so that units within the same group can be placed in one group and units which are dissimilar can be placed in other groups. Multidimensional scaling actually give you a graphical way of looking into that particular idea, right? It is not exactly the graphical form of cluster analysis, but the idea is very much closer to cluster analysis. For example, without actually going into the discussion how this is actually carried out right now, there is also another very popular name in the literature for the multidimensional scaling, MDS, and that name is, as you can see here. Have you heard this name before? आप में से किसी ने ये नाम सुना है? Perceptual mapping? या नहीं? Anyone?
Perceptual mapping means the scaling of the perception of the customers regarding a product.
Like, for example, where you place the product, right? On the basis of your perception of the product. And you have, for example, customers se puchte hai na, you ask a series of questions from the customers regarding different characteristics of a product or a number of products, okay? And then, for example, you just want to make what you call a perceptual map. And perceptual map would actually, in a sense, group the products. Suppose there are competing products in a particular market, and the perceptual mapping technique, jisko hum MDS kehte hain, multi-dimensional scaling, it would actually, on the basis of the perceptions or the responses given by the customers, it would try to place the products in the form of a multi-dimensional space, right? Where the products plotted or lying similar to each, closer to each other, would be, in a sense, telling you that they are very much closer in their characteristics to each other. That's why they are lying very close to each other. And the products which are quite different from each other on the basis of information provided by the customers, they, in a graphical sense, would be plotted somewhere else, right? So the closer those products are to each other, the closer are their characteristics. And the farther those products are from each other, the farther are their characteristics, right? So this type of graphical way of placing the objects into a space is actually what we call perceptual mapping, okay? It may not be just the products, but for example, products is just one example. What you see on the screen right now is just a simple example without actually mentioning the method, but this is just, for example, a study of 6 business schools in US, Harvard, Stanford, Wharton, Chicago, Carnegie, and MIT, okay? And on the basis of some characteristics measured on these business schools in the form of different variables, you can imagine that you have data on these business schools, which was represented in the form of different columns, right? Different information related to different features of these schools. And then analyzing those features on these business schools, the technique of MDS came up with something that you can see on the screen, right? Placing those business schools closer to each other, which are somehow very closer in their features, in their characteristics, on the basis of the data analyzed. So as you can see here, 3 business schools, okay? Harvard, Stanford, and Wharton, they are actually lying in one particular portion of this 2-dimensional space. Carnegie and MIT are actually at other place, while Chicago is at a different place. So even if you don't go into the detailed discussion of this particular structure for the time being, at least you can just get an initial idea that why Wharton, Stanford, and Harvard are actually placed very closer to each other, because on the basis of information, multivariate data available on these business schools, they were in a sense declared to be comparatively closer to each other, or what we say similar to each other, right? Okay. By similar, I don't mean that they are exactly the same, but by that we mean that they are very much closer in the characteristics measured on them, right? Similarly, Carnegie and MIT, they were found to be much closer in the features that you had measured on these business schools, while Chicago was actually standing out, not very much closer to these 3 or the other 2, right? This sort of structure in the form of a graphical presentation is what we call perceptual mapping. So perceptual mapping is a graphical way of determining the proximity or the closeness of the objects in your study, right? As I said, objects can be respondents, objects can be customers, the objects can be institutions, they can be students, they can be, for example, animals, depending on what is actually the unit of information in your study. So MDS can actually help to place the objects in your study, in a sense, the rows in your multivariate data in the form of a structure, which can be quickly understood, because it is usually said that a picture is worth 1,000 words. Many people, particularly those who are not good at numbers, they feel more comfortable when they look at a graphical presentation. So therefore, MDS just give you this graphical presentation that we call perceptual map, okay? And this is sometimes very useful for further analysis. So therefore, this is one of the purpose of MDS. Okay. This was one of a very quick discussion of some of the multivariate techniques, although there are so many others, but I think I should actually stop this discussion of techniques over here and come directly to the first technique that we call PCA, okay? So let me open up the file that I hope I would send you today. अगर आपके पास नहीं है तो मैं आज आपको ये सेंड कर देता हूँ. This is a short document of 8 pages, okay? A handwritten document which was written in one of my lectures in previous sessions. So one of the previous students had kindly provided these things to me कि अगर आप लोग इसका फायदा उठा सकें, okay? So this is just giving you a quick summary of the technique of PCA. The first thing that you should remember about PCA, let me, is it visible? या इसको मैं large कर दूं?
Visible है sir.
Okay, all right, okay, thank you. So the first thing that you should remember about PCA is that it is a variable focused approach, which means when you will be carrying out this technique, you'll be looking at the data variable by variable. Yeah, just come get a column focused approach, right? So this technique basically analyzes or compares the columns representing the variables in your multivariate data. Another thing, which of course is not part of this document, but I hope from the discussion that we have just done, PCA is basically an interdependence technique, okay? Because PCA does not require that you should mention which variable is dependent and which variable is independent. It considers all the variables in one go and then carry out certain, because as will become clear from the objective, PCA does not require dependence versus independence. So this is actually an interdependence technique. Okay, so what we do in PCA, PCA is basically an exploratory technique which takes data on the given variables. That is the original data, right? By given variables, I mean something like this, as I have already mentioned. Suppose you have data on X1, X2 up to XP, the different columns in your multivariate data. And through a transformation, through a technique that we call a transformation technique, that we call PCA, we get new variables. Those new variables are given the name PCs, principal components. That's why this technique is called principal components analysis, right? So the name to the new variables are PCs, principal components. And for the purpose of our discussion, we will be denoting those new variables by the Y notation. Okay. So if X1, X2, XP are notations for the actual variables, then Y1, Y2 up to YP would be notations for the new variables. And how these new variables are defined, such that every new variable, PC, is a linear combination of the actual variables. Okay. Each of this, whether it is Y1 or whether it is Y2 or whether it is YP, all of them are defined as a linear combination of this. This would become clear what I mean, but PCA works like this. Okay. This is the main idea behind PCA. You have the original data. You have the original data on the X variables. You apply a technique that we call PCA. And as a result of that technique, you come up with a new set of variables, which you represent by, for example, Y1. Remember, Y1, Y2 are arbitrary. You can use any other notations. But for the purpose of our discussion, I would say if X is a notation for the actual variables, then Y would be the notation for the new variables. These new variables would then be given the names of principal components, right? In which the first one, Y1, would be called the first PC, the second would be called the second PC, and so on, right? The YP would be called the P PC or the last PC. And all of these Y1, Y2 are obtained by using an idea that we call linear combination. Now, what is linear combination? Okay. Linear combination is a simple idea. In one sense, I have already described this idea in my previous discussion. Linear combination is an idea in which you define new variable from the old variables in this way. Remember when I was explaining the concept of asset index, I have already told you that if X1, X2 up to XP are representing responses on different household assets, then you combine this information in the form of A1X1 plus A2X2 up to APXP, and you come up with a new variable, and that new variable in a sense represent those original variables, right? So this would be what we call linear combination. And we call it linear combination because if you look at the right-hand side, not only the constants A1, A2 up to AP, not only they are occurring with the highest power of 1, but the variables x1, x2 up to xp, they are also occurring with a highest power of 1. So therefore, the right-hand side is actually what we call a linear function. So what is a linear combination? Linear combination is basically a weighted sum of variables, right? There's a difference between simple sum and a weighted sum, because in simple sum, you will be adding just x1, x2, and xp. But in a weighted sum, you assign weights to each variable, and then you add them up. So rather than simple sum, if you just go for the weighted sum, then this weighted sum is actually what we call the linear combination, okay? Just to give a very quick idea of linear combination and why we do it, because linear combination idea is at the heart of PCA and factor analysis. So therefore, you should all be very clear what is linear combination and why we do it. What is the purpose of taking linear combination of the variables, okay? A very simple example would actually clarify everything. For example, you had applied for admission into PhD program and you were given admission on the basis of information provided in your admission form. For the purpose of our discussion, we would say that when you apply for an academic program like PhD, one simple approach would be just to consider only one aspect, only one credential. Like, for example, your previous academics, okay? If you are given or not given admission on the basis of your previous academics, then this would be a very simple process. But usually when you are apply for a graduate program or a PhD program, academics, although very important, would not be the only criteria that is considered for your admission. For example, the admission authorities decide that academics would be one aspect that we will consider, but we will also consider two other aspects. We will keep an entry test, which will tell us, for example, something about the suitability of the candidate by just confirming something apart from academics, whether this person has requisite potential to be considered for our PhD program or not. And then they say that another important process that we will be considering will be the interview process. We will also judge the potential applicant in interview. And they say, then they also decide that in order to emphasize the importance of each of these three things, we come up with a weighting scheme. 30% for academics, 30% for entry test, and 40% for the interview, okay? So they come up with a procedure like this, as you can see here. They say for each applicant, we are going to use this particular formula. 30% means 0.30. So 30% weight would be assigned to X1. What is X1? Academics. Another 30% weight would be assigned to X2. X2 is your performance in the entry test. And the remaining 40% would be weight assigned to X3. So they can come up with some formula for determining the aggregate on the basis of which they can just create a merit list. And 0.30 X1 plus 0.30 X2 plus 0.40 X3. And any applicant who actually is applying for the program, for every applicant, they would have information on these three aspects, X1, X2, X3. They will plug in those information over here, and they can come up with a single measure. So if you look at this particular idea, 0.3 X1 plus 0.3 X2 plus 0.4 X3, this is nothing but something like this, okay? If you call aggregate is a new variable represented by y. Why we call it new variable? Because this is a variable obtained from 3 original variables. And if you say this is of the form a1x1 plus a2x2 plus a3x3, then in the given case, a1 is 0.30, a2 is 0.30, and a3 is 0.40. So this idea, this is nothing but simply what we call the LC, the linear combination. So linear combination is an idea which is very much part of our daily processes. The only thing is that maybe we have not used this word LC before, but I hope when I have just introduced this idea, you will discover that the idea of linear combination is nothing new in our daily life. In most of the processes, people make use of this idea of linear combination, okay? This example is in terms of admission program, but I hope you can extend it to so many other processes in real life where the decision is going to be made not on the basis of a single feature, single criteria, rather on the basis of multiple criteria, okay? You can also extend it to job selection. When you apply for a certain job, maybe the selection authorities for the job decide that they will not consider only one aspect. Ji? Exactly. Even performance evaluation ki baat jab aap karte hain na, right? So, for example, when you want to decide which employee is to be promoted to the next cadre and which one is not going to be promoted, so even over there, the authorities can use similar idea. They can come up with a number of characteristics of the employees, okay? And they can get scores. For example, using certain criteria, they would say, okay, we have scores on these different dimensions. And then rather than simply adding them up, they would come up with some weighting scheme, right? Just like 0.3, 0.3, 0.4, they can just come up with some other weighting scheme, and they can decide that we would assign appropriate weight to each feature of the employee, and then come up with an idea of LC over there. And it would be actually the linear combination that would be actually used to decide promotion criteria or other things. So the thing is that this idea of linear combination is very much part of the processes in our life. Even jab kisi industrial unit mein ya kisi bhi business unit mein, when they are, for example, trying to determine the performance of their sales representative, right, or salesman, so even over there, they can consider different performance measures of the salesman in their organization. So they would initially get results for all the salesmen in their organization in the form of X1, X2, X3, X4. And then they would say, okay, let us try to combine information on all these original X variables into one or more linear combinations. And on the basis of that linear combination, they can then make a decision about further policies. One thing that I should actually mention before I can specifically come to PCA, that, for example, in a given situation, you can consider more than one linear combination. अब आप देखें यहाँ पे ना, the linear combination that you can see on the screen right now, it is constructed in such a way that, for example, X1 is given the weight 0.3, X2 is given the weight 0.3, while X3 is given the weight 0.4. Suppose this criteria was followed by Qurtuba University for giving admission into their PhD program. So I would say that this sort of thing is actually what I would call Y1, because this is the linear combination used by Qurtuba University. Suppose Peshawar University or any other university